So in lesson number 3, we're going to explore some additional wireless LAN controller features, as the title slide says here. Actually, we're really only going to look at one additional feature in this chapter, and that is how we deal with client link technology. So we're going to talk about what it is, kind of more in depth, and we're going to look at how we can configure this. Remember, this is a feature that is used to support legacy clients and do things like beamforming and other things to enhance the capabilities of some of these other clients that may not support all of the other features that exist in modern wireless networks. Okay, so we'll take a look at that in this lesson, and then we'll wrap up this lesson and move on. Client link, and I'm just going to focus primarily on version 3.0 because that's what most modern AirOS operating systems will run, is a beamforming technology that's going to enable the access point to optimize the signal level at the position of where the client is placed. The whole goal is to improve my signal to noise ratio and reduce the number of retries, get higher data rates, and so on. It does this by allowing the wireless system to operate, or it provides the ability for the wireless system to operate at higher data rates in how it handles multipath and the multipath functionality. Basically, we're just trying to use the spectrum resources more efficiently. The CLI refers to configuration changes as beamforming. Now, the AP has to have the following capabilities. Client link capability, of course, that's what we're talking about. You have to have 2 or more antennas enabled for transmission, and you have to have 2 or more antennas enabled for reception. Can't get this client link capability without that. It's not supported for data rates of 1 meg, 2 megs, 5.5 megs, or 11 megs. So you need to make sure that you're using the higher data rates as well. All right. If you want to configure it, it is a feature that you can enable globally. When you're in the command line, you type config 802.11. In the case of A, you could type config 802.11a beamforming, all one word, global enable, and it simply turns on the feature. There really aren't a whole lot of other things that you have to configure in order for this function to work. It's just simply a feature that you turn on. Now, there are some customization things that you can enable, and we'll talk about that over the next few slides. But very important to note, you cannot turn on this feature in the GUI. You have to do it through the command line interface. I don't know if there's plans to change that in the future, but as of right now, that's the case. Again, config 802.11a or b. Remember, this is for legacy clients. You're not going to do this in N because we already have MIMO in N, and you're certainly not going to do it in AC. So config space 802.11a or b, beamforming, global. You can also enable it on a specific AP, by the way. You have to give the AP name, and then you just enable it or disable it. Okay? All right. Now, band selection is another option that you have. That's going to enable client radios that are capable of dual band to join a less congested frequency. We talked about that before, where you have 2 bands operating. The AP can respond on either band, that it's available to service the client, but then the client can then, well, the client's going to join whatever band is advertised in the beacon anyway. So the AP delays the response of the more utilized band, and so the client ends up joining the first band that it sees. That's essentially how it works. Band selection, and it's all done, by the way, by regulating those probe responses that I talked about. The idea is that we're trying to make channels on one frequency spectrum more attractive to the client by delaying those probe responses for channels on the other frequency. Now, you can configure this particular feature through the GUI, which is what you see on the screen here, or you can do it through the CLI. So we see a couple of different options here for band select. By the way, this is not beamforming, right? It's just another technology that we can use in the B space and the A space to provide additional protection or to provide for more efficiency for the clients themselves. All right, so you see a lot of settings here. I want to describe what some of these settings represent. So if you do happen to want to configure this, at least you know what values are here. Cycle count, that's basically the number of times a client probe gets suppressed before allowing it. So in this case, we're going to suppress two client probes. Cycle threshold. That is the time that an AP waits before it increments the probe cycle count. Okay, now when does that occur? The AP only increments the count if the difference of the time between the latest and the last probe is more than that configured value. All right, so anything less than 200 milliseconds in this case would not increment the cycle count number. Age out suppression, we can see that configured as well. That's a timer that for suppressed client age out entries in the controller. What I mean to say by that is if a client at a maximum, stays on a channel for about 300 milliseconds during the initial scanning, and if there are a total of, say, 40 channels to scan, the client will come back to the same channel about every 12 seconds. So if the AP doesn't receive a probe from that same client within that time period, the AP then assumes that the client has gone offline or has associated to a different AP or maybe even on a different channel. That's the age out suppression it represents. Age out dual band. The AP will not respond to a 2.4 gigahertz probe until a dual band client is no longer marked as dual band, right? So that's going to prevent the clients that are associating on the 5 gigahertz radio from switching back to the 2.4 gigahertz radio if it in fact sees that message or that information in the beacon. And then client RSSI. This particular setting allows the filtering out of clients that are, have low signal strength. We're excluding them from the band select feature. So in this particular case, anything at minus 80 dBm is going to get excluded. All right. Now the band selection operates only on access points that are controlled by the wireless controller. Flex Connect access points, for example, without a controller, don't perform the band selection after you reboot them once you've configured them for Flex Connect mode. The band selection algorithm itself directs dual band clients from the 2.4 gigahertz radio to the 5 gigahertz radio on the same access point. It only runs on the access point when both the radios are up and running. So I can't direct a client to, say, a different access point that has the 5 gigahertz radio running just because I may not be running that 5 gigahertz radio. So it's not possible to enable or disable band selection and client load balancing globally on the controller, but you can enable or disable band selection and client load balancing for a particular wireless LAN. All right, so now you know what the client band select checkboxes represents. Load balancing means, hey, this client has sufficient RSSI to connect to 3 different access points within the same SSID and the same extended service set. Based on my AP load count, I'm going to go ahead and direct you to go to a different AP. All right. Be careful with the band select option. I've run into this situation for sure. You have real-time environments like voice over IP environments. You do not want to use the band select option because of the amount of time it takes to roam from one access point to the other. So just be aware of that. That's something that you have to be aware of. If you're running into a situation where voice over IP is dropping calls and you're getting jitter and packet loss, check to see if that feature's turned on. Okay. When a wireless client tries to associate with a wireless network, you can determine the client type from the information that you receive in the messages that are exchanged between the client and the controller. So the controller is going to collect the information, and then it can pass that information along to other devices. Now, the only device that I've ever dealt with that actually is concerned about profiling information is ICE, the Identity Service Engine. ICE is going to use that information to profile the client, determine the policy that's going to be applied to that client, and we already talked a little bit about ICE having all these features to do onboarding, device identification, posturing, policy, and so on, remediation and whatnot. Okay. Now the controller provides some of these capabilities locally, right? So the controller can act as the collector of the information, profile the devices based on the MAC, the OUI, HTTP information, DHCP information, and so on. But again, it doesn't really take action against that data. It's collecting that information so that it can pass that information along. Okay. Now we can also do client profiling. We talked a little bit about that just now, but we can go into it in a little more detail, right? Because just like ICE, profiling and policy enforcement, they're kind of two different elements. Profiling allows me to kind of identify what the device is, and then the posture that I take or the policy that I take depends on that profile. The controller uses different attributes to determine which of the 88 pre-existing profiles the client or device should be assigned to based on that information. Could be user group, user role, Windows clients, smartphones, tablets, what SSID did they use, the location, time of day, what kind of extensible authentication did they use, and so on. We can configure the device-based policies and enforce per user or per device policies on the network. We could do that in the controller. Typically, we would do that in ICE. We'll pass this information along to ICE. ICE will evaluate the information and then respond to the controller to apply things like a VLAN or an ACL, a quality of service level, timeout values that are enforced for the client, and so on. All right, so we do have that capability. When you're using the controller to apply these policy actions, those actions are taken after the authentication is complete, whether it's the layer 2 or the layer 3 authentication. Actually, the actions could also be taken if we send HTTP traffic and the device is actually profiled. Maybe we're doing some sort of web auth as well. So profiling and policy actions occur more than one time per client. It just depends on how you've configured your policies and your policy actions. That's very different when you're using ICE to provide whatever your policies are and to determine what those policies are. While the controller parses all the DHCP profiling information, every time the client sends a request, that profiling information is sent to ICE only one time. So once I've identified the device, unless the profile changes, I'm not going to send any additional information to ICE. We can also do local profiling. You can see here under the Advanced tab, there are check marks for DHCP profiling and HTTP profiling, meaning that we're simply monitoring the machine for those packets, and inside those packets we're able to capture, in the application layer data of those packets, we're able to capture information about the device. So you go to Edit the Wireless LAN, go to the Advanced tab, make sure that AAA override is disabled. That's important. Check the boxes that you want. Am I going to profile this device based on DHCP messages, HTTP messages, or both? Go to Monitor, go to Clients, and this is where you can see that. So if I come in here, you'll notice on my screen here, I don't have any information populated under the SSID for top operating systems, top applications. If I go to advanced, go to my wireless LANs, go into my wireless LAN, go to advanced, and I enable the profiling features. Let's do local profiling. Yeah, okay, that's fine. And I enable that feature. Now, oh, no, can't do that. I would lose my connection to my WebEx here if I did that, but you get the idea. You can enable those features, and then you'll start to get that information on that home screen. That's where we're getting that information from, all right, as well as other information that's listed on this home screen. But I don't want to lose my connectivity to you guys. No, it's not really configurable. You just simply turn it on, and it starts monitoring all those different transactions. Now, you do have the ability of setting up local policies. You don't necessarily have to use ICE to define policies. If you go to security and then you go to local policies, you create a policy. There are a few things that you set up. It's kind of hard to read here, but I'll see if I can go through some of these settings here. The match role string, excuse me. This is the user type or user group of the user. Is it a student? Is it a teacher, etc.? Match the EAP type, the device type, and so on. And then we specify an action area. Am I going to apply an IPv4 ACL policy? Am I going to assign a VLAN ID? Am I going to assign a QoS policy? Am I going to apply session timeout parameters? Am I going to identify sleeping client timeout parameters, and so on? All right. If you want to go ahead and apply this policy, I think you guys might actually have a lab where you work with this a little bit later on. You want to apply the policy, you go into the wireless LAN, select the SSID, and then go policy mapping, and then specify the policy. You can have up to 16 policies for a LAN. Priority indicates the order of operation for those particular policies. So we talked about Client Link, the use of Client Link and its capabilities. MIMO, how we enable APs to improve legacy client signal levels. How do we enable Client Link from the CLI, right? I told you guys that command. I probably should have written it down for you in Notepad. Band select, what that does. How can I enforce band select per wireless LAN? And then how do we set up local profiling to apply specific policies based on profiling the clients themselves. That concludes that lesson. We'll go ahead and break from this lesson, and we're going to move on to the next lesson where we get into some more detail on client provisioning and whatnot.